How can you help the brain repair itself and reconnect after a stroke? Let us first see how the brain can repair itself after an injury. For years and years, we were told that we develop a fixed number of brain cells when we are born that will just die in our lifetime, losing thousands and thousands of neurons. In the 1990s, scientists have proven that this is not strictly true. Neurogenesis is the formation of new brain cells, which occurs also in the adult brain and results in the production of new neurons. We now know that after an injury, the brain attempts to repair itself, but this is often only partial, allowing only incomplete recovery. After a stroke, neurogenesis will start the proliferation of neuronal precursors, or progenitor cells, that have the potential to develop into new brain cells needed to repair the brain. These progenitor cells result from the differentiation of stem cells present in some parts of our brain. They have the potential to later become fully functional neurons, which may take over the neurons that have died. But we know that the conditions and environment around the area of the brain damaged by a stroke is not ideal. And so those new cells actually cannot easily incorporate and become neurons on their own. Obviously, one of the main questions that scientists have to solve is how to amplify these natural processes for increasing the number of new neurons and ensuring that they become incorporated functionally in the brain's circuitry. Another priority is to ensure that as many cells as possible will survive in the brain. The healthy cells around the area of stroke will provide an important resource within the area of the damage that can help in the repair process. Called neuroplasticity, together with the new neurons generated by neurogenesis. In and around the area of stroke, there are a lot of cells that are surviving but starved for oxygen and nutrients, called the ischemic penumbra. The sooner the supply of oxygen and nutrients can be reestablished, the more likely those cells will survive. Scientists continuously search for better ways to harness this phenomenon and encourage greater proliferation and migration of new cells to areas that have been damaged in the brain, in the hope of restoring physical functions that were lost because of a stroke and other brain injuries. Now, let us look at how we can help the brain repair itself and reconnect further. The most common way to enhance the brain's potential to repair itself and reconnect after an injury is to stimulate it by performing rehabilitation exercises. Are there other ways to improve and amplify the repair process and help the brain to reconnect? NeuroAid